On this channel, we provide useful programming information with practical code examples. This time, we'll be talking about the shared worker in JavaScript. We will explain everything from the basics of shared worker to practical use cases step by step. Enabling subtitles will make the code descriptions easier to understand. A shared worker is a worker thread that can be shared among multiple pages, tabs, windows, iframes, etc., within the same origin. Unlike a page-specific, dedicated worker, the main feature is that a single background process can be shared among multiple pages. Typical use cases include the following. You can share a single WebSocket connection across multiple tabs, reducing the number of connections and centralizing reconnections. You can synchronize state between tabs, centralized management for pub, sub or stores. You can serialize IndexedDB operations, mediating simultaneous access. You can prevent duplicate execution of computationally expensive processes. Shared worker has a different role from service worker. Service worker mainly acts as a network proxy, while shared worker focuses on performing arbitrary calculations or state management shared across pages. This code shows how to create a shared worker and send, receive messages through its port. This code demonstrates how, inside the shared worker, a message port is received for each connection in processes and replies to messages from clients. Shared worker starts when the first connection is established and may terminate when the last port is closed. Connections are closed upon page reload, close, and the worker is recreated if needed. Shared worker is a long-lived script shared within the browser. If you are not mindful of the shared worker lifecycle, issues such as resource leaks, stale state persistence, and unintended restarts are more likely to occur. This is a minimal implementation where multiple tabs connect to the same shared worker, and any message sent is broadcast to all tabs. This code connects to a shared worker, implementing message reception, display, posting from a send form, and sending a ping by clicking a button. This code implements a simple pub sub feature inside the shared worker to relay messages between multiple clients. If you open this page in multiple tabs, messages sent from any tab will be notified to the others. When multiple clients interact with a shared worker, you often want to identify which response corresponds to which request. Therefore, it is standard practice to include a correlation ID to associate responses with requests. This code implements a simple RPC client that can make asynchronous method calls to the shared worker. Here, an RPC server, Remote Procedure Call Server, refers to a server that provides a mechanism for calling functions and procedures from other programs or processes. In this example, the ID is simply incremented, but you could also use a UUID, a random string, or combine a timestamp with a counter to create a unique key. This code implements a simple RPC server that executes processing according to the method and sends the result back together with the request ID. There are several practical patterns when using shared worker, such as the following. If each tab opens its own WebSocket connection, it will affect the server load and the connection limit. Place just one WebSocket in the shared worker, and each tab receives messages via the worker. This code implements the process of sending, receiving messages to a WebSocket server and receiving connection status notifications via shared worker. This code implements a mechanism inside the shared worker to share a single WebSocket connection, broadcasting connection status and received data to all clients, while sending each client's outgoing requests to the server via the WebSocket. By centralizing reconnection strategies and unsent message queuing in the shared worker, behavior becomes consistent across all tabs. When accessing the same DB from multiple tabs, if you want to avoid conflicts from simultaneous transactions or lock waiting, you can queue them in the shared worker and process them serially. This code implements a mechanism where read-write operations to IndexedDB are queued via the shared worker, serializing access from multiple tabs to avoid conflicts and lock contention. If you want to write your shared worker script as an ES module, behavior and support can vary by environment. In practice, it is safer to choose one of the following. Write in classic worker format and use import scripts to load dependencies if needed. Use the worker entry feature of your bundler, such as Vite, Webpack, SBuild, etc., and create a separate bundle for the shared worker at build time. Consider the following points for error handling and robustness. Handling sends before connection is established. Queue messages that arrive before the port is ready. Disconnection detection. Message port does not have a standard on-close handler. On the main side, send a type by message with port. Post message during, before unload, or otherwise clearly specify in the protocol to ensure the worker is cleaned up. Reconnection. When a page is reloaded or a tab is reopened, a new port is created. Prepare an initial synchronization message to send the complete state at once. Back pressure. During heavy broadcasting, switch to throttling, debouncing, or sending snapshots. Security. A shared worker is fundamentally shared within the same origin. If placing secrets inside the worker, consider designing side verification with tokens or similar means for the calling side. Each type of worker has the following characteristics. Dedicated worker is intended for use by a single page only. It enables a one-to-one separation of computations from the UI. Shared worker can be shared across multiple pages with the same origin. It is ideal for inter-tab communication and sharing a single connection. Service worker can be used for network proxying, caching, offline operations, push notifications, and background synchronization. Its strength is the ability to intercept fetch requests. As a rule of thumb, use shared worker for information sharing and arbitrary processing between tabs, service worker for network control, and dedicated worker if you just want to offload heavy processing from the UI. When using a shared worker, you need to be careful about the following points. Forgetting to call, start, or unnecessary invocations. When using port, add event listener, message, you must call port, start. This is unnecessary if you use port on message equals. Unrestricted broadcasting. The load increases as the number of tabs increases. You can reduce the load by implementing differential delivery or subscription topics, filtering by topic. Copy cost of objects. Post message duplicates the data. For large data, consider sending it as transferable, such as array buffer, or using shared memory, shared array buffer, together with atomics. Lifetime and reinitialization. Shared worker may terminate when the last client disconnects. Properly design initialization for first connections and restarts to avoid side effects and bugs. Shared worker is a place to implement long-lived custom logic shared across multiple pages. Clarify the message contract, types, protocols, and make your request-response design robust by attaching correlation IDs. It is ideal for processes that work better when unified across all tabs, such as multiplexing WebSocket connections or serializing access to IndexedDB. Fine-tuning details such as bundlers, type definitions, and reconnection can greatly improve maintainability and user experience. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Your support keeps this channel motivated. Please subscribe to the channel.